So far, we have learned how to record measurements using significant digits, count the number of significant digits in a number, and we've learned how to round to a given number of significant digits. Now we will learn to round calculations to the correct number of significant digits based on two sets of rules. First, multiplication and division. Second, addition and subtraction. So first, let's do a review problem for recording significant digits correctly from scaled instruments. Remember, you are always going to read between the lines. So record the values and then see if you get the right answer. Okay, so here are the answers that I recorded. Notice that I rounded everything to the 100ths position because the scale was marked to the tenths. You may have disagreed with me slightly at the hundredths position. For example, for B, you might have said 1.33 or 1.35, but the point is that you were recording to the 100ths position. Let's review the rules for counting significant digits. You learned that trailing zeros are significant, show precision, only if there is a decimal point. You learned that leading zeros are never significant. They are just placeholders. And then you learned that exact counts and exact conversion factors are treated as having an infinite number of significant trailing zeros. For example, a dozen contains exactly 12 things. So let's do a review problem for counting significant digits. I want you to pause the video and see if you can get the answers correct. All right, so here we have 40200 has three significant digits. Those trailing zeros are not significant. 0.0402, the underlined digits are significant. 8,000, because there is no decimal point, only the leading 8 is significant. In scientific notation, the entire coefficient is significant. 0.7090, the leading 0 is not significant. In 0.005, the leading zeros are not significant. And the trailing 0 in 50 point is significant because of that decimal point. So let's take a look at how we're going to use significant digits when we round with calculations. In multiplication and division, the final answer must match the least number of sig figs in the problem. So if we have 2.00 times 0.50, our calculator says it's 1. However, we're going to record as 1.0, and that's because 0.50 has two significant digits, 2.00 has 3, so our final answer must have two significant digits. In our next problem, the 0.5 is going to limit significant digits. So we only have one significant digit. So our calculator answer is 1, and we will record as 1. 3 times 1.5. 3 has only one significant digit, so it's going to limit our answer to one significant digit. Our calculator says 4.5. We will round the value to 5, one significant digit. 10 point divided by 12, or 2.50. 10 point, because of that decimal point, has two significant figures. So our calculator says 4, but we know we need to have two significant digits, so we record 4.0. 10 divided by 4.05, in this case 10 lacks the decimal point, so there's only one significant digit. The calculator says 2.47, it's going to round to 2. Here are some practice problems for you to attempt, so get out your calculator, try these problems, and then check the answers on the next page. In this case, the 0.25 limits us to two significant figures. 8 times 0.25 limits us to one significant digit. 5 times 1.3 limits us to one significant digit. 20 point divided by 5.0, the 20 point limits us to 2 significant digits. And then we have 20 divided by 6.9. In this case, there's no decimal point, so the 20 limits us to 1. In addition and subtraction, the rules are different. Now we're going to round the answer to the least known place. So I find it easiest to think of these as lining up the problems, and what you want to do is line up the decimal point. In this case, we have 12.08 and 1.5. Here we know the 0.5 only to the tenths position, so we're going to round to the tenths position. In the second problem, we know the -1 only to the ones, so we round to the ones. In the third problem, 30.0 limits us to the tenths, so we're going to round to the tenths. Here are some sample problems for you to try. Pause the video and try the problems. Okay, here are your answers. 1.2 is good to the 10th, so we round to the 10th. 9 is good to the ones, so we round to the ones. 32 is good to the ones, so we round to the ones. All digits in scientific notation are significant, so if you get stuck in a calculation answer, switch to scientific notation. Scientific notation will always be correct. So in this case, 20 point times 500 point. The 20 point limits us to 2 significant figures, but 10,000 has only 1 significant figure. So what we're going to do is to put this in scientific notation, and 1.0 times 10 to the 4th, the 1.0 has 2 significant digits. In our second example, 21 times 94.8 is 1990.8, so we're going to have to round to 2 significant digits. But we're going to find that we're going to get stuck. So we rewrite in scientific notation. We're going to round to 2 significant digits, so it's going to be 2.0 times 10 to the 3rd. Here is a final practice for you. Pause the video and try these problems. Okay, here are the answers. I have underlined the significant digits. You can pause the video and check to make sure you have gotten the correct answers. All right, in AP Chemistry, we're going to have do significant calculations for multi-step calculations. And this is going to take some practice, so really I'm just introducing it to you here. So we've got this problem here, 18 minus 15 divided by 12. The first part of this is we would calculate 18 minus 15, and using subtraction rules, the answer would be 3. Notice when we write this that this is only 1 significant figure, okay? Our next step is divide that value by 12. This 3 limits us to 1 significant figure, and we're in the multiplication and division, so we are going to be limited to 1 significant figure. Let's try another one. Consider 21.0 times 3.0 divided by 59, or minus 59, excuse me. The first part of the problem follows the multiplication rule, so we're going to have 3 significant digits because each of these values has 3 significant digits. Next, we're going to subtract 59, but this is only good to the ones, which means that our answer can only be good to the ones. So our final answer is going to be 4. All right, that is it for significant digits.